The children will continue to use all the multiplication tables facts up to 12 times 12 when working on division, and they're very likely to extend this work to go beyond the normal tables. So they might learn things like 3/17 or 51, and they may use that to find related facts. So 51 divided by 3 must be 17, 51 divided by 17 must be 3, 510 divided by 170 must be 3, 510 divided by 17 must be 30, 510 divided by 3 must be 170. Using their knowledge of place value, they will learn to divide whole numbers and decimals by 10, 100 or 1,000. So they really need to understand the columns very well. Obviously the units, the tens, the hundreds, the thousands, the 10,000, 100,000, million, 10 million, 100 million, billion. But over to the right, next to units, there's a decimal point, but the next column is the tenths, the hundredths, the thousandths, and so on. They may be asked to find the answers to questions such as 68 divided by 10, and their knowledge of place value is such that they'll know that the 6 that was in the tens will move to the units, the 8 that was in the units will move to the tenths, and so they'll reach the answer 6.8. Or 73 divided by 100, dividing by 100 moves numbers 2 places along, so the 7 will move into the tenths column, the 3 into the hundredths column, and then we'll put a 0 in the units. Here's 89, we're going to divide it by 1,000. So to divide by 1,000, each digit will move 3 places to the right. So let's move the 9 first. 1, 2, 3, it goes into the thousandths column, and the 8, 1, 2, 3, it goes into the hundredths column. And so because the tenths column is empty, they'll have to fill it with a 0. Not forget the decimal point, and a 0 in the units. So 89 divided by 1,000, 0.089. They will continue to practice dividing 2-digit numbers, 3-digit and 4-digit numbers by 1-digit numbers using formal written short multiplication. So here's a couple of examples. 6,744 divided by 3. And they'll be used to saying, how many 3s in 6? There are 2. How many 3s in 7? There are 2, but there's 1 left over. How many 3s in 14? There are 4, because 4 3s are 12. So we've got 2 left over. How many 3s in 24? There are 8. The final answer of 2,248. 2,279 divided by 4. So they'll say, how many 4s in 2? There aren't any, so put the 2 and the 2 together. How many 4s in 22? There are 5, with 2 left over. How many 4s in 27? There are 6, with 3 left over. And how many 4s in 39? There are 9, with 3 left over. And so they can write 569 remainder 3. But they could choose to use that remainder 3 with the 4 to make a fraction. So the answer is 569 and 3 quarters. 569 and 3 quarters. Or they could find an alternative answer. So the same question, how many 4s in 2? There aren't any. How many 4s in 22? That's 5, with 2 left over. How many 4s in 27? That's 6, with 3 left over. How many 4s in 39? That's 9, with 3 left over. And they could extend the division into the decimals by putting the spare 3 there. How many 4s in 30? There are 7. 7 4s are 28, so there's 2 left over. How many 4s in 20? There are 5. 3 correct answers to the question 2,279 divided by 4. They will need to decide which answer to present to a problem. So, for example, if the problem was there are 2,279 pupils in a large secondary school to be split into 4 houses, how many will there be in each house? They could say, well, there'll be 569 in each equal-sized house, but there'll be 3 pupils left over. And obviously the problem might end up with 3 houses of 570 and 1 of 569. Or, for example, they could be measuring a distance of 2,279 kilometres, dividing that by 4, 569.75. They will also be extending their skills in the process of long division. 9,176 divided by 37. 37 into 9 certainly won't go. So how many 37s are there in 91? Now here they can use intelligent guessing. They know it's going to be more than 1 37. It could be 2 37s. Could it be 3? 3 37s. Well, 3 30s are 90, and we've still got the 7 to deal with, so 3 is too many. so they know it's going to be 2. Now they may use their mental skills, or they may do some jottings. 37 times 2, 7 2s are 14, 3 2s are 6, 1 more makes 7. So they know they've got to subtract the 74 they've used to create the two 37s. 1 take 4, 11 take 4 is 7, 8 take 7 is 1. Bring down that 7. How many 37s in 177? Well, they might say 37's roughly 40. 4 40s are 160, so it's probably 4. Let's find out. 37 times 4. 7 4s are 28. 3 4s are 12. Add 2 makes 14. That's 148. Yes, there's not enough to make 5 37s. We now subtract the 148. 7 take 8. Cross out 7, but 6. 17 take 8 is 9. 6 take 4 is 2. Bring down the 6. How many 37s in 296? Well, I'm going to guess 7, but I might be wrong. Let's try. 37 times 7. 7 7s are 49. 3 7s are 21. Add 4 makes 25. That's 259. Have we got enough for 8? Let's find out. 37 times 8. 7 8s are 56. 3 8s are 24. Add 5 makes 29, which is exactly what we've got. So the answer comes out as 248. These are jottings. Some people prefer to actually write out the 37 times table. So 137, 2 37s are 74, 3 37s 111, and so on. I personally prefer the jottings system. The children need to practice. Confidence in knowing how to find the answers is the key to mathematical success.